Okay, good morning and welcome to this course on the distributed and outsourced software engineering, also known as those. The course will be taught by Dr. Peter Kolb, who is not here today, but who will be here in most of the coming weeks. He is not full-time at ETH, he's a consultant for industry. He has his own company, Red Expel, and he's active in particular in advising companies on the software process and on topics related to this course, that is to say, how to organize the distributed and especially the outsourced development. So the second co-teacher of the course is Martin Audio, who will now say a few words about himself.
So, my name is Martin Audio. I've been teaching this course with Bertrand for the last 5 or 7 years. So we have started in 2005 with a course about outsourcing, and then we started to incorporate a distributed project in 2007, and I'm the manager of the distributed project. So at the beginning we had a few universities working together, and now we got up to 11 last year, and this year we have 13 universities all working together in this project.
And I'll say a little more about the project. Now actually we'll say a lot more about the project for the rest of the semester. You're going to hear a lot about it, and I hope not only hear about it. The assistant for the course is Christian Essler.
Yeah, hi, so I'm Christian. I'm a second year PhD student in Bertrand Meyer's group, and I was last year for the first time assistant for this course, so I now already have some experience, which is really good for you. And if you have any problems, I'm the first person to contact. And then I will answer if I can, and otherwise forward it to Martin.
And someone who did not pass the criteria for being an assistant to the course this time, but was an assistant for the course previous years, is Julian Shannon. I'm joking, he's no longer an assistant for the course, but he likes it so much that he comes out and he comes back again. And as far as I'm concerned, my title is Professor of Software Engineering here at ETH, and also have an industry association with iFull Software, which is the company where I worked full-time before I came here in 2001. So, a bit of technical, more practical information. The course page is easy to find. This is the URL. You will find all the material for the course there. And this also includes the project description at this particular URL. So make sure you have at least the first URL, which includes a pointer to the second one. So what we want to do in this course is listed here. As Martin just recalled, this started out as a course initially taught by Peter Kolb and myself in starting, I believe, in 2004, 2003 or 2004. I think it was 2004, which was called Software Engineering for Outsourcing. What led to this course was the realization that outsourcing, the phenomenon of software outsourcing, had become a major part of modern software engineering, and that in fact many, if not most, software projects were being outsourced, but there was very little mention of this in the software engineering literature, and so we were one of the first software engineering courses. I actually think we were the first anywhere to be devoted to this topic of outsourcing entirely. And then it became clear after a few years that although outsourcing was of course very important and the initial motivation, when it comes to software engineering challenges, then the mere fact of outsourcing is not enough to talk about the issue. What really matters is the fact that the various components of a team are distributed geographically. So you might have a traditional outsourcing situation with a customer team, say here in Switzerland, and a provider team in Bangalore in India, but there are many different variants. For example, it can be the various parts, the various divisions of a company that work together to produce some system, or it could be any combination of insourcing, outsourcing, backsourcing, these buzzwords that you may have heard. And what really raises a problem from the viewpoint of software engineering is the fact that these streams are distributed. How do you build software with people who are halfway across the world, whose night is your day, who don't quite speak the same language as you do even when you try to use a common language when you interact, who have a different cultural background, maybe work for a different company, have different assumptions. That is really what counts. And the fact that it's outsourced is part of the problem, but it's not it's only one aspect, and many of the issues appear even if you are not outsourcing, even if you're just in a distributed development team, for example, within a company. So at that stage, we decided to rename the course from Outsourcing for Software Engineer, or the other way around, Software Engineering for Outsourced Development, to Distributed and still Outsourced Software Engineering. And we also decided shortly thereafter to practice what we were describing by making the courses still distributed. Well, in fact, not the course really, because the course is still being held in one place and in other places, but each university has its own course, but the project. So what we decided to do was to organize with the collaboration of our colleagues in different universities around the world, to have a distributed project where students from different universities would collaborate, so that we wouldn't just talk about the issues and techniques of developing developing software in a distributed fashion, but we will also give students the opportunity to touch and feel these issues and practice the solutions hands-on directly. So the course today is largely built around this project, and we're going to talk more about it. Coming back to the course proper, our goal is to help you understand the fundamental issues and techniques of software engineering, the specificities and technical challenges of distributed software development, including and in particular in an outsourcing context, but not restricted to it, know how to organize distributed projects, participate in them, and also manage them, and you'll get a hands-on experience of doing this. We want you to understand the effect on the outsourcing phenomenon on the industry and manage your own career accordingly. This is particularly true for people, for example, here or in general in places that are the customers of outsourcing. There's clearly a certain amount of angst around as to the effects of outsourcing on the IT profession, and we'd like to cover some of this as well. So these are some of the topics that we cover: challenges of distributed software development, the outsourcing phenomenon proper and its evolution over the years, how to organize a distributed project, how to perform the requirements for a distributed project, what process models are appropriate, how to negotiate with suppliers, in particular the notion of service level agreements, which Peter Kolb will cover, and also quality assurance and testing for distributed projects. So the background is that we have had a major transformation of development over the past 15 years. It's actually still a fairly recent phenomenon. It started occurring en masse in the late 90s, and we developed in the first decade of this century. There's been a massive transfer of development efforts towards specialized suppliers, largely in lower wage countries. Outsourcing by itself is not new. It has existed for many years, for decades. In fact, companies, for example, that didn't have a big information technology department themselves were very used to contracting out their developments to large software companies like IBM, like Electronic Data Systems, like Capgemini, and many others. So that is not new. What is new is the massive nature of this phenomenon and its geographical change from mostly local outsourcing in the 70s and 80s to remote offshore outsourcing. This is, of course, only the application of the application to software of a trend that has developed for several decades, starting with manufacturing, where much of the manufacturing of the world is nowadays done in China and other lower wage countries, and it continued with design, with low-level service jobs. Then things like call centers started to be automated, customer support centers. Then India made a name for itself, as we're going to see in more detail, with low-level implementation tasks, and then little by little the level of what outsourcers have been able to do has risen to the point that some countries today offer very high-level outsourcing services, including not just implementation, but design or even requirements. So this is why we are doing this course. The techniques exist, although they are not completely known. So for example, there is no textbook on the topic of this course. There are books here and there. We will cite them as we go. There are books, for example, that explain to you how to do business, specifically software business with India and things like that. There are books that explain to you how to organize an outsourced project for effectiveness, but there is no software engineering book which takes the viewpoint of this course, that is how to organize your software development from a technical software engineering perspective for a distributed situation, how to adapt all the activities of software engineering from requirements to design to implementation to maintenance to testing to documentation and so on, how to adapt all of this to a distributed environment. So this is also kind of a sneaky way to push some of the ideas that are actually not so sneaky, because we are pretty open about it, but it's also a good opportunity to teach again some of the concepts that software engineering courses teach anyway, concepts of abstraction, concepts of API design, of good documentation, and requirements. So asking the students in the room for a moment, how many of you have taken the ETH curriculum so far, as opposed to coming from other universities? Okay, only 3. So you've taken the software architecture class in second year. Did you take it from Bertrand Meyer or from me previous year? Okay, that's what I thought. Yeah. And actually, yeah. So I'll ask everyone in fact to introduce himself or herself in a couple of minutes. So I'll ask you more details in a moment. So, but still, just in the level of a show of hands, how many of you have taken a general software engineering course? Okay. So just to make a couple of spot checks, how many of you have heard about CMMI? You should raise your hand. You have heard about it.
I didn't quite understand.
CMMI. How many of you have heard about CMMI? I'm not going to ask any deep technical question about about half. How many of you have heard about fault injection? Okay. Just a spot check for me. Okay, so now I'm going to talk a bit about the project, and I have been told that, we all see that this first part of the lecture is being recorded, and the reason is to show it as well to students and teachers in universities participating in the project. In fact, yeah, so these are the universities involved. Yeah, this is how it has grown over the years. It started with ETH University of Zurich, which is across the street, so it's not exactly an outsourcing situation, just very distributed situation. And then in 2008, we added the Politecnico di Milano in Italy, University of Debrecen, and so this year, this is the list. And I'd like to, since some of the students are going to see this by video, I'd like to take this opportunity to welcome all the students from the other 12 universities that are taking part in this project. And you can see that it's rather diverse, from Egypt to Vietnam to Russia to Ukraine, Milan in Italy, Rio Grande in Brazil, Nizhny Novgorod again in Russia, Greece, Crete, Debrecen in Hungary, Rio Cuarto in Argentina. I wonder why we have the University of Rio Cuarto, University of Zurich, which is closest to us. Is there any student from the university in this room? Yeah, okay. And I think for practical purposes, do we actually make them part of ETH groups? Yeah, okay. So the University of Zurich is not really remote. Do you know if there are any other students from the University of Zurich taking? Probably not, right? So you're probably and then Universidad Politécnica de Madrid in Spain. So you can see that it's a really diverse set of countries and institutions, and it's going to be fun to discover the teams and learn to work with them. So let me explain a bit the background behind this, because the formula is tuned quite carefully. I don't mean it's perfect, and we have been improving it every year based on experience, but we have given the issues a lot of thought. One of the issues when you have a project in a software engineering course is how much to emulate an industrial setting. Of course, such a course is meant to prepare students for software development in industry, but we shouldn't go too far. The university is not a company. I mean, if we were to emulate completely, 100%, an industry setting, you might just as well go to industry right away, and you might even get paid for that. So what's the point of going into a course in a university if it's to do exactly what's done in a company? And in fact, I mentioned the notion of being paid. One of the big differences, of course, between an industry setting and an academic setting is that money plays much a bigger role in an industry context than it does in an academic setting. It's essentially not a factor. So we can pretend to a point that we are emulating an industrial setting, but only to a point, and we need to know where to stop. To explain a difference, to show a difference on the other side, in companies you don't get grades. You may get evaluated every year and promoted and so on, or not, but you don't have this notion of grade for a project or for a course. So the benefit of being at a university is that indeed it is not a company. We have a controlled setting, and for example, the consequences if you mess up are, well, they're going to be maybe that you get a less good grade, but no rocket is going to explode and no one's going to get killed, at least. That depends on the topic of the project, but we have selected the project topic accordingly. So it's a control setting, and the purpose is to learn, right? The goal number one is to learn. Actually, I should have said that the goal number two is to learn, and the goal number three is to learn as well. Essentially, the only goal is to learn. All groups are created equal. So because we started with an outsourcing course, you might have thought that we would have divided the groups between, for example, order givers and order takers. For example, the group that does the specification and the group that does the implementation. We explicitly decided not to do this for several reasons, but perhaps the main reason is that in software engineering, in my experience, it's very easy to handwave. So it's very easy to write a glorious specification in which the system is going to do everything plus coffee in the morning. Right? Well, there's nothing to check you, unless you have to implement the stuff. So the situation, which unfortunately I've seen quite often in industry, in which you have a team doing the analysis, specification, sometimes even the design, and then a team doing the implementation, and the design can be on either side. This is a very dangerous situation. It's actually a very dangerous situation in industry. I've seen this time and again in industry where a company hires a consultant who produces a magnificent set of requirements and a beautiful design, and then leaves. He doesn't have to have any responsibility. He has left a few responsibilities behind, and then someone else has to deal with the result and actually implement it. But there's nothing to keep the guy honest, to make sure that what he or she has defined is feasible. Only if you know that you are going to have to live with the result of your plans do you have an incentive to limit yourself to something reasonable. So that is the main. So I'm talking about industry. And by the way, one of the lessons for industry, although it doesn't heed that lesson at all, is never, and I repeat, never hire someone to do analysis or analysis and design. This is a recipe for a catastrophe. And, you know, if you hire someone for your project, make sure that the person is there to be also responsible for the results of his or her graduate plans. Coming now from an industry context to a university context, the same observations apply. So we could, of course, have had a team in location A draw the specifications, and then a team in location B perform the implementation. But then how do we know that the team in location A, the specifying team, is going to limit itself to something reasonable? We don't. Okay. So what I've done in some projects, but we're not doing here, it can work, is a situation in which we actually have this specification and implementation done by different teams, but each team does a specification and an implementation. So you basically exchange teams at some point. So this is fairly complicated to organize, and sometimes it works, sometimes it doesn't, so we're not doing this here. So the idea is that each team is going to have to produce a system from beginning to end, and so you live up to the requirements that you have produced at the beginning. Something which is like in a project in industry is that any project must have a clear management structure. So the responsibilities are well defined. There's a central management role, and currently the king, no, that's not strong enough, the emperor of the project is, or the god, okay, let's be honest about it, is Martin. So this is like in industry, right? So in the end, the buck stops somewhere, someone needs to have final say. It also means final responsibility. If things don't work, we know whom to blame. I know whom to blame. But that is always the case in any decent industry project. There's someone in charge at the end. So it doesn't mean it should be at ETH forever, but for the moment this is where it is. And also as an industry, the basic technology choices are imposed. So we use Eiffel as the programming language and method, and Eiffel Studio as the development environment. Well, actually there's a little more to say about this. We use web-based tools, and in particular there's a new tool that we have developed as a development environment, which will be used for this. Martin or Christian will say more about this later on. And the situation is not one way. The flow of information doesn't have to be one way. So we record our lectures, or at least some of them, and we are very interested in contributions from other universities involved. There are, as you will see, among the topics of the course, there are some on which we have a really good material, some on which we could benefit from expertise that exists in other universities. So I'm saying this in particular to the instructors seeing this video from other universities. If you think that on one of these topics or on a related topic which is important for the course, you have a good lecture, please don't hesitate to contact us, and we'll be happy to broadcast it and to use it for our own purposes. So the way it works is that each group is made of a number of teams. So it's important to note that terminology to avoid any confusion. What the set of people, the set of students who prepare a project, who do a project, is called a group. And a group is made of typically 3 teams. For example, we might have team A1, B1, and C1 forming group 1, and then teams B2, C2, and D2 forming group 2, and so on. And each team is made of students, typically 2 or 3 students in one university. So in this picture, team A1 might be an ETH team, and this might be ETH. this might be Nizhny Novgorod, this might be Politecnico di Milano, and so on. So you see the idea, we combine teams from the different universities, teams of typically 3 students, and the division of the work is between the team, but the division is not that one team does the specification, the other team does the implementation. The division is a functional one. That is to say, we take the problem and we have divided it into 3 pieces. Surprise, exactly 3 pieces. The groups have 3 teams. Now you can question this division. Right? If you want to organize yourselves differently, that's fine. I don't advise it because there's not that much time, and we have planned the division carefully. But you have a lot of freedom within the general framework that we've defined. So we've divided the project into 3 parts, and then you organize yourselves to decide which team does part 1, which team does part 2, and which team does part 3. So this is not the first time we do this. As I said, we have refined the formula over the years, and we don't do the same thing exactly every year. We change a bit for variety, but over the years, lots of students have participated in the course, and I think I can say enjoyed it. Now, when I say enjoyed it, I have to be careful here, because I have to warn you that there are sometimes, especially towards week 3 or 4, in our experience, there can be some difficult times because communication is difficult. Right? You are going to be starting to work with students who, as I said earlier, speak a different form of English from you, and your English is so much better than theirs, except that they think yours is terrible and they think so. So they speak so much better English, and then you're going to have to interact by Skype or whatever communication mechanism you find most convenient, and sometimes the communication is going to break down, and sometimes you'll try to reach them and they're not available, and the other way around. So it can be tough, and there can be some frustrations along the way. What we have seen over the years is that at the end of the course, students really have the impression of having learned a lot, and they tell us so. So I'm not promising a path of roses. There can be quite a few bumps along the road, but what I hope I can promise is that you will learn a lot, and that at the end, it will have been a very successful experience. So what this also means, and this is very important for everyone, in particular for ETH students, actually no, I shouldn't say this, it's important for absolutely everyone. I don't know if there's a slide which says it, but I'm going to say it now. Anyway, don't drop out late. Okay. So what is the deadline for dropping out? Our deadline?
October 2nd.
October 2nd. Okay. So this is regardless of any administrative deadline imposed by the ETH. But the point in this course, especially with this emphasis on the project, is not necessarily for everyone. So if you decide after a few days or a couple of weeks that this is not for you, we won't hold it against you. We'll remain good friends, right? No bad feelings, but if you there's this principle sometimes applied in program design of fail early. So that's exactly the point. Fail early, right? If you decide you're not going to do it, decide it before October 2. This is the absolute deadline. And after that, if you're in, you stay. And the reason for this is very simple. You can guess it, right? In the scheme that we have, it breaks total havoc if suddenly a person or two, or worse, a whole team vanishes. So until we've started for good, that is to say until October 2, it's not a major problem, we can reconfigure, but after that, it becomes a catastrophe. So I don't know how well I can carry the idea. So let me just beg you, please, if you're going to resign from to drop the course, drop it before October 2. Is this handled enough? Or, captured on video. So I heard the message is clear. So yeah, so this was the first year. Actually, it looked like we had very few people. This was the first project presentation. The first year we did a project in 2007. This also enables you to catch a glimpse of Peter Cole, as well as a slightly younger and beardless. Martin, that's you, right?
Yes.
The next one. But in fact, even though there were not so many people in the room, there were actually maybe 50 people attending this presentation because people were attending it remotely through Skype. It was already was Skype video in 2007. Okay, so you can, I encourage you to browse a little bit, I mean, to take a few glimpses from some of the project demos from previous years. So you will see that your predecessors have produced some quite interesting programs. And well, this year we hope that it will be even more exciting. So what it means for ETH students is that the grading is entirely based on the project. In the year until the year before last, we also had an exam, and then we decided to remove the exam entirely because the project is really the focus of the work, and we don't want students to be distracted. So the grading is entirely based on the project, and the project will be due December 17th. And when we say December 17th, we mean December 17th, right? It's absolute deadline. That's paradoxically one of the aspects that is more stringent in academia than in industry, right? One usually thinks of industry being a harder context than academia in terms of software development, but in industry, a project can be late. Actually, the project fairly often is late. Well, usually you're just sorry that it's late, and usually it also means it's going to cost more than expected, but it's better than having no project at all. In academia, well, we have to give you a grade, and our colleagues in other universities have to give their students a grade, so there's no way we can slip as compared to industry. And there will be a presentation on December 18th, which I believe is a Tuesday. It's in class, yeah, it's in class. There will be the project. Actually, I don't think I'll be here on December 18th, but I'll make sure. Yeah, thanks. Martin knows my calendar better than I do, but I'll make sure I attend the presentation remotely, because I'll be at ITLO and I should be able to attend. And that's the whole idea, right? The whole thing is distributed. Do you want to say a few words about the assignments, Martin?
Yeah, so we usually have several assignments that are distributed over the different teams and groups. So most of the assignments are team-based, so it's local teams, but there are a few assignments that are group-based, where the whole group has to produce one document. So we first start with the setup of the team. So Christian is going to put the assignment online in the next few hours, and what you have to do is to create your own team at ETH, give us the name, emails, and Skype IDs, and then we will form the groups, and you will start to communicate with your partner. So we are going to have groups with three teams, so you will be working with 2 other locations, so ETH and 2 other locations. So then all the deadlines are in the Zurich time zone at 9 a.m. So, and these are strict deadlines, so we won't be able to move any deadline. So you have to make sure that you get to these deadlines. The deadlines are not really final. We are waiting for a reply from Milano about this deadline, but I think we won't move much the deadline. So the first deadline is about the scope management plan. So basically, the project will be games, and you will have the choice of selecting the games you want to implement, but then you have to agree with the other 2 teams how you are going to implement the games and how you are going to distribute the tasks. We are not going to tell you exactly what you have to do and what the others have to do, so you will have to discuss with them who is in charge of each component. So each game will be split in 3 components: UI, logic, and AI. And then you will have to discuss with them who is doing what. And it's up to you to agree with them who is doing what and what you are going to implement, so which game. So Christian will put a list of games that we suggest that are big enough for a team of about 10 people, 8 to 10 people. But then you are free to choose the games you want as soon as the complexity is similar. So you have to justify why the game you want to implement is big enough as the other. So with respect to previous year, we want to have more complex games. We are not going to accept very simple games as like previous year, the Uno game or poker games. So it has to be something more complex because we have 10 people working together. I think we have learned a lot about distributed software development, and I think we can do much better than previous years. And then
but still, the complexity of the games is a bit variable, right?
Yes. So
what I was going to say, you can still decide based on how much work you want to put into the course, take a slightly easier or slightly more complex game. It cannot be very easy, it cannot be, well, actually it can be very complex. It cannot be very easy, but it can be more or less easy.
Yes. So then the second assignment is about requirements document, and what you will have to do there is to write the requirements for the part of the component you are going to implement. So once you agree with the different teams who is doing what, then for example they will decide that this team here will do the AI for game X. So then what you have to do is to write a requirement for this AI component, and then you will deliver one document for the requirements document, for the assignment 2. So then this means that the other teams are also going to write one requirement document for the component they are implementing. So there will be 3, at the end for each group there will be 3 requirements documents for each part of the components. We don't require that you put the requirements document together, but we suggest that you try to use the same terminology. For example, there will be a lecture by Bertrand talking about requirements that you should write a glossary, and then we recommend you to share this glossary among the different teams in the different locations. So the assignment 3 is about the API design. So we will write the API design using design by contract, and what the design by contract will do is it will let you express the functional properties of your API. So and instead of only writing the signature of the API, you will write what are the requirements and the insurance of these functions. And you will have to do it again specifically for your subcomponent, but you will have to synchronize with the other teams whether this API is good enough for the others, because the other teams are going to use your API. So what is new in this year is that we changed the testing, and we are going to do Testdriven Development in assignment 4 to check that the API design is good enough. Basically, in this assignment, we will switch the teams, and then the teams who is doing the UI, for example, is going to write the test for the team doing the logic, and the logic is going to do for the AI, and the AI for the UI. So each teams will write some tests, and then we'll tell the other teams whether the API design is good enough or not, and if they need some modification in order to check whether they can use the API or not. And then so you will have 1 week for this, and during these weeks you can change the API design because you realize something may not work. And then in the final assignment you will have to do the implementation, and so for the implementation assignment you will have some midterms deadlines where you will have to show us what is the progress of the project, and you will have to do some demos during the exercise sessions. And also for all these assignments, if the assignments are for 2 weeks, you will have to deliver a draft by the 1st week. So in all the assignments you will get at the beginning says the draft, the date for the draft and the date for the final assignments, and these are firm deadlines, so you have to satisfy the deadlines. And then we have a presentation.
I'll open the floor for questions in a couple of minutes, just in case you have questions. So I think Martin has already said this.
So can you go? So to the architecture. Yeah, well, one thing is important is that for the implementation phase, what we are going to do is to implement only one system where we will share the code among all the students in all the universities together. So Christian, I think Christian will create the main UI for the game, and then there will be different clusters for the subcomponents of the different groups. So there will be one cluster game 1, with game 2, and game 3, and so on for each group. But then we will share all the same repository. So this means when you check out the repository, you will compile the whole project. So then if a guy in Vietnam breaks the code, then you will break the code of everybody. So then you will have to use the tools to be able to go back to the previous revision and then compile the previous revision. So this is why we are putting all the people together for 2 reasons. First, to learn lessons about distributed software development. So you are not working isolated in a sub-team and then you do your own work. You have to share the stuff with other teams. And then also to learn how to use the tools, because many of the problems can be solved very easily just by using the tools, like configuration management tools and good communication. So then all the teams will be part of the same repository, but then no one is allowed to touch your code. So there is some strict rules about where you are allowed to commit. So people from game 8 are not allowed to touch the code that you change in game 7, for example. And then the same happens with the components base. So people that is working in the same group as you is not allowed to change the code that you are writing. So unless you give them the right to do the changes. And then each game will be, we will suggest to organize like UI, logic, and AI. But then the discussion is, what does it mean? Where do you break the subcomponents? And this is up to you, and this is one of the difficult parts of the project at the beginning. So, for example, you take one functionality and then you say, is this functionality part of the UI or the logic or the AI? So, and then you have to discuss for all the functionalities you want to implement. Yeah.
Okay, great. Thanks, Martin. Okay, so that's for ETH students. So the exercise sessions are before the course, before the class every week. They don't take place today, but it will take place starting next week. And the deadline for the first assignment, we have all been brought up with C. So we are kind of somewhat distorted minds, and the first assignment is called assignment 0. That's what it comes. What happens when you have nerds teaching a course. So assignment 0, the first assignment is scheduled for October 2nd. Okay, now before we break, I'd like actually, these are. I mentioned that lots of students have participated, and that this is a great opportunity to meet students from completely different places. And I'd like to finish this first hour by by having some short self-presentations of the students in this room. Don't give us the full story of your lives, but if you could just tell us briefly what your background is. In particular, I think there's a majority of transfer students from other universities. So what university you come from, well, your name and whatever you may have done in software engineering before, which prepares you for this course. So maybe we can start with that and look into the camera. Yeah. I didn't bring a card.
So hello, my name is Paul Bielik, and I'm from Slovak Technological University in Bratislava, Slovakia. And previously I focused mainly on recommendation systems in software engineering.
Welcome to ETH.
Excuse me?
Welcome to ETH. This is kind of for factor out for everyone.
Yeah. So my name is Gisli. I'm from Denmark. I study computer science at the University of Copenhagen. I'm taking the general computer science path.
My name is Stefan Zoflo. I completed a bachelor's in mathematics at Bern, and now I'm enrolled here on the software engineering path. I've worked for a short time in industry.
You said Bern.
Yes, Bern. That's it.
My name is Paolo Antonucci, and I come from University of Rome, La Sapienza in Italy, where I studied computer engineering.
So my name is Adam Davidson. I come from England, London. I studied computer science in the University of Portsmouth, and I'm working and studying. I'm on the MTech program here at ETH.
Hi, my name is Amida. I am second year of my master's here. I am doing my second year of master's here in ETH, and I am doing general computer science track, and I have done computer science at my bachelor in Turkey.
In Croatia?
In Turkey.
In Turkey.
Hello, my name is Kamaljeet Kaur. I come from India and I have done my master's in computer applications. And now here I am for a certificate course for 1 semester.
Hello, my name is Loredana Bamanu. I came from Romania. I did my bachelor at University Alexandria Kuzan. It was computer science. I also have a little bit of work experience, actually 1 year and a half. And I'm in my second year of master here, following information systems track.
Hello, I'm Vytautas Astrauskas. I'm studying software engineering at Vilnius University, and I am doing my Erasmus exchange here. And actually, I don't have any experience in industry, but just have a theoretical background. That's all.
I'm Karthik Sundararajan from India. I studied my bachelor in India and I'm doing second year master program in University of Zurich. It's a computer science specialized in software systems. And I was working as a part-time employee at ICOM in Zurich. So the best solution.
Okay.
My name is Maksat Pernebaev. I am a student of University of Zurich, so I am studying my third semester in software systems as well, the same specialization. So I did my bachelor in Kazakhstan.
In Kazakhstan?
Yeah.
I'm Tim Karpowski. I did my bachelor at ETH, and I'm now studying the master with the specialization track of software engineering.
Hi, my name is Mark Krent. I'm currently enrolled in bachelor at ETH, and I've quite some experience in working. I'm working part-time. Yeah.
Hi, my name is Florian Besser. I'm enrolled here in the Masters at ETH, also specialization in software engineering. And, well, I've also done my bachelor here and worked part-time in the last year.
Great, thank you very much. Of course, the diversity is quite impressive. In fact, one way to have a distributed course is to send you all back home, and then you could, it could be almost as distributed as the course we have here, but that's not the idea. So I hope we can have a few video introductions of other students in other universities as well, so that people get to know each other a bit. Any questions on the organization of the course or on anything on which we have touched so far? Okay, so if not, we make a break now for 15 minutes, so it means we start again at 20 past 11, and then we continue with the first topics of the course.
So the assignment 0, and in fact it's called assignment 0 because we had the plan of the assignments from previous years, and I didn't want to go through all the documents and change all the numbers. And then I created assignment 0. It was much easier.
I thought this was to make me mad because, of course, in IFO, numbering starts at 1, so I thought this was just one.
No, it was an easy way to create a new assignment. So it's to create the teams, the local teams, and it's not possible to have a team of 1 person. So you have to be at least 2, and maximum 3. So then you can talk to each other and try to discuss if you want to create a teams, and then how to create the teams. So we have plenty of time for the first assignment.